Part 2 of Unit 9 is about concentration of solutions. Okay, in this section we're just going to cover several different ways of expressing solution concentration, and the first one we're going to talk about is mass percentage. The formula for calculating mass percent is mass of A. A is our solute in this case, divided by the total mass of the solute and the solvent multiplied by 100. Because anytime you have a percentage, you're multiplying by 100. That's going to equal your mass percent. So it's a pretty easy calculation. So if we wanted to figure out the mass percent of a solution that has a total mass of 100 grams, and it was made by dissolving 13 grams of sodium chloride, 13 divided by 100 times 100, that's just going to equal 13% by mass. Mass percent is pretty easy. Parts per million, ppm, and parts per billion, ppb, are very similar to mass percent, except you're not going to be multiplying by 100, you're going to be multiplying by something else. So for parts per million, it's the mass of your solute A divided by the total mass. But instead of multiplying by 100, you're going to multiply by 1,000,000. Or another way to write that would be 10 to the 6th. That's going to be how you find parts per million. That was an ugly M. For parts per billion, hopefully you can kind of guess at what this is. It's the mass of A, your solute, divided by the total mass, solute plus solvent, and you're going to multiply by 1,000,000,000. Or another way to write that would have been 10 to the 9th. That's going to be how you find the concentration in parts per billion. So they're real similar to mass percent, you're just not multiplying by 100, you're multiplying by either 1,000,000 or 1,000,000,000. Next is mole fraction. This is given the abbreviation capital X for some reason. So to solve for a mole fraction, it's going to be moles of A over the total number of moles. That's going to be moles of solute plus the moles of solvent. Now with mole fraction, you can solve for the mole fraction of the solute or the mole fraction of the solvent. It depends on what the question is asking you. If it's asking you to find the mole fraction of the solute, the number on top is going to be the same thing as the moles of solute that you have in the solution. If they're asking you to find the mole fraction of the solvent, you just put the moles of the solvent on top and divide by the same thing. When you add the mole fraction of the solute to the mole fraction of the solvent, they're going to equal 1. So if you know the mole fraction of the solute and want to find the mole fraction of the solvent, you just subtract it from 1. Next up is molarity, abbreviated with a capital M. If you don't know what this is by now, I'm impressed you made it this far. But molarity is moles of solute divided by liters of solution. Not liters of solvent, but the total volume of the solution. Now this can be treated as kind of an algebra problem where you could be given the concentration and volume of a solution and asked to find the number of moles. Well, to find the number of moles, you would just multiply the volume times the molarity. That would give you the moles of solution on the side of the equation by itself. If you were trying to find the volume of a solution, it told you how many moles and what the molarity was. So if you're trying to find the volume, you'd be trying to solve for liters. So what you would do is move liters to this side of the equation and then move molarity to the other side. So to solve for volume, it would actually be moles divided by molarity. We have another important equation related to molarity. It's our dilution equation. M1 V1 equals M2V2. This works kind of like a gas law equation. If we know the concentration and volume of a stock solution and the volume we're diluting it to, we can find the new concentration of that solution, or the other way around. You just end up solving this for one variable. So let's say that I want to dilute 18 molar sulfuric acid. I want to dilute it down to 6 molar, and I want to make 2.5 liters of it. Well, I can plug that stuff into this equation to figure out how much of the 18 molar sulfuric acid I need to make 2.5 liters of 6 molar sulfuric acid. I plug 18 in as my M1. I'm solving for the volume of the stock solution, the concentrated solution. I'm trying to make 6 molar solution, and I'm trying to make 2.5 liters of it. So to solve this, it's 6 times 2.5 divided by 18, and that's going to equal 0.833 liters of the 18 molar sulfuric acid. So what I would do is I'd put 833 milliliters of 18 molar sulfuric acid in a volumetric flask and dilute it to 2.5 liters total volume. Next is molality. It's very similar to molarity, so similar that they even have the same letter for an abbreviation. Molarity is capital M, molality is lowercase m. Molality is moles of solute, that was ugly, per kilogram of solvent. So it works real similar to molarity, it's just moles of solute per kilogram of solvent. If you know the density of a solution, you can convert between the molarity and molality of it, because the values are not going to be the same. So in this example, we need to find the molality of a 0.75 molar solution if the density of that solution is 1.11 grams per milliliter. Well, what we'll do is we'll start our calculation with 0.75 molar, which is the same thing as moles per liter. So we've got 0.75 moles per 1 liter. We can use the density to convert between volume and mass. So we've got to go from liters to milliliters first. So in 1 liter, that cancels that out, there are 1,000 milliliters. And the density tells us that for every 1 milliliter, it's got a mass of 1.11 grams. Now, molality is moles per kilogram, so we can't stop there. We've got to convert grams into kilograms. So 1,000 grams per 1 kilogram. By doing that, we've gone from moles per liter to having our final units be moles per kilogram, which is molality. So 0.75 times 1,000 divided by 1,000 times 1.11. This turns out to be 0.68 molal solution. So the molarity is 0.75, but the molality is 0.68. That's how you can convert between the two using the density of the solvent. Your question for this section: what is the mole fraction of solute when 0.5 moles of sodium chloride are dissolved in 150 grams of water?